Good morning, students. Welcome back to Digital Learning of Science and Technology. Hope you all are fine and safe at home. Today we will study a very interesting topic in Science 1. That is lesson number 4, Effects of Electric Current. This lesson consists of three major topics. First one, energy transfer in electric current. Second one, heating effects of electric current. Third one, magnetic effects of electric current. In this lesson, we will also study about an electric current flowing through a conducting wire, an electric current flowing through a resistor, electromagnetic induction, electric motor and generator. Let's see few questions from Can You Recall? First one, how do we decide that a given material is a good conductor of electricity or is an insulator? Some materials are good conductor of electricity and some materials are bad conductor of electricity. That is insulator. First we should know about good conductor and insulator. Conductor is defined as the material which carries the electricity, or in easy language we can say that the material which allows electricity or charges to flow through it. Also remember one point that conductor have very low resistance. The material which has high resistance are called as bad conductor or insulator. Example, rubber, wood, plastic, glass, etc. If the material have high resistance, the flow of electricity in it will be less. If the resistance is low, more electricity will flow through it. That material is called as conductor or good conductor. Example, silver, copper, aluminium. When we talk about insulator, this is completely opposite to definition of conductor. It means we can say that they do not carry the electricity or they have high resistance. But how do we decide the material is good conductor or bad conductor? Let's recall the experiment which you have performed in previous class. Touch the open end of two wires to each other to form a circuit and test the bulb. Touch the two open end of the wire to each material you are testing one at a time. If the bulb lights up, then it is good conductor. If the bulb does not lights up, then it is an insulator. As you can see in the following example, rubber and pen are insulator, key and pin are conductor. Next question, iron is a conductor of electricity. But when we pick a piece of iron resting on ground, why don't we get electric shock? When we pick a piece of iron resting on the ground, we don't get electric shock because there is absence of electricity. Here electricity means flow of charges. You can also say that there is no potential difference between person and ground. That is why person does not get any shock. Therefore students, when we sit on metal table or chair, we do not get shock through it because there is no flow of current. So wherever the electricity flow, there will be potential difference and we will get a shock. If there is no potential difference, electricity will not flow and we will not get a shock. We have learned in earlier standards about static electricity and electrical charges. There are two types of charges, positive charge and negative charge. Some objects we say are positively charged and some objects we say negatively charged objects. To prove this, we have performed various experiments regarding positively charged and negatively charged object. Like we have rubbed our hands, we have rubbed silk cloth with glass rod, we have rubbed comb on hair, etc. With the help of following experiments, we saw reason behind the object becoming positive and negative charged is the transfer of negative charged particle from one object to another object. Now let's observe the following pictures and find the answer for the following question. What do you observe in the following pictures? We can see lamps, TV, computer, electric fan and electric bell. Next question. Which effects of electric current do you find? You can observe production of light in lamps, heating effect of electric current in fan, magnetic effect of electric current, conversion of electric energy into mechanical energy and conversion of mechanical energy into sound in bell. We have studied a concept in 9th standard, that is free electron. Student, this is a metallic wire. Electron possessed in the atom of this metallic wire has one speciality. It can jump from orbit of one atom to orbit of another atom. And you can say that electron which can jump from orbit of one atom to orbit of another atom is called as free electrons. Conductor consists of this free electron because of which they can make a movement. Wood, plastic does not consist of this free electron. Therefore, there is no free electron, then there will be no movement in electron. If there is no movement, the current will not pass. A material is good conductor. It means what is present in it? Free electron, which makes the conductor a good conductor of electricity. Next, you have studied a formula I is equal to Q upon T. I means current, Q means charge and T means time. Next, you have studied a formula potential difference. Potential difference is denoted by alphabet V. Potential difference is equal to the amount of work done upon charge transfer. V means potential difference, W means work done and Q means charge transfer. If electron moves in the conductor, that means work is done. And if work is done, how much charge is carried, that will be potential difference. Next, we have studied resistance. Resistance is equal to potential difference upon current. R means resistance. The ability of a conductor to resist the flow of current through it is called resistance. When current is flowing in wire, each metal has its own capacity to resist. Resist means to stop the current, that it should not flow. If number of electrons is more, then more will be the resistance. Because electron only will resist the conductor, so we can say that R is equal to V upon I. It will be potential difference divided by current, that is resistance. You also have studied resistance in series and resistance in parallel. Resistance in series formula can be written as Rs is equal to R1 plus R2 plus R3 plus Rn. And formula for resistance in parallel can be written as 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus upon R3 plus 1 upon Rn. Rn means total number of resistors which are connected in circuit. This is the symbol for resistor which we use in circuit, and it is indicated by R. Similarly, there is one rheostat in which we can change the value of resistance. If suppose the value of resistor is 50 ohm, its value remains fixed. We cannot change the value of resistance. If we can change the value of resistance, then it is called as rheostat. And we can show symbolically rheostat like this or this. For example, if we consider a speed of a fan, it can decrease and increase using rheostat. Next, we have studied resistivity. The symbol for resistivity is rho, and formula for resistivity is resistance into area upon length. Next, we have studied power. Here, power means how much fast the work is done. For example, to draw the water from the well, there are two options. You can draw water using bucket or you can use motor. How much water is necessary? Till that time we will keep the motor on and then we will off it. Which method is more suitable and work done is quick? Yes, student, we can draw water quickly using motor because its power is more. So therefore, power is how fast or slow work is done, and the formula can be written as power is equal to work done upon time. Now let's see SI unit of all these systems. SI means system internationally accepted. Units like kg, liter, meter, kilometer, etc. These all are unit accepted internationally. For example, the SI unit to measure the distance is meter. Similarly, I stands for current. So, symbol for current is I. The SI unit of current is ampere, which is denoted by A. Next is Q. Q stands for charges. The SI unit for Q charges is coulomb, which is denoted by C. T stands for time. The SI unit of time is second. V stands for potential difference. The SI unit of potential difference is volt. W stands for work done. The SI unit of work done is joule. R stands for resistance. The SI unit of resistance is ohms. Resistance in series and resistance in parallel also have the SI unit ohm. Next, the symbol for resistivity is rho, and the SI unit of resistivity is ohm meter. How do we get ohm meter? The formula for resistivity is rho is equal to resistance into area upon length. The SI unit for resistance is ohm. The formula for area is length into breadth. The SI unit of length is meter and breadth is meter. Therefore, unit for area is meter square and the SI unit of length is meter. When you simplify this, we get ohm into meter upon meter. Meter gets cancelled and therefore resistivity becomes ohm meter. That is, the SI unit of resistivity is ohm meter. Now next is power. The SI unit of power is watt. Students, you can note down this SI unit of system in your science notebook. Our next topic is energy transfer in an electric circuit. As you can see, this is an electric circuit. Black line indicates that all the wires which are used in the circuit. This is battery. The symbol for battery is E. This is ammeter. Ammeter is used to measure the current flowing in the circuit. To measure how much current is flowing in the circuit, we use ammeter, and symbol for ammeter is A. Voltmeter is used to measure volt. That is, how much potential difference is there. To measure potential difference, we use voltmeter. This is connected with positive terminal of the battery, so it is denoted by plus, and this side of the voltmeter is connected with negative side of the battery, so here it is denoted as minus. And this blue line indicates that it is a resistor between AB and it has fixed value. Where resistor is attached, the whole length of resistor is called as AB. So therefore AB is the length of resistor. Now, how much potential difference AB has? To measure that, it has to be joined with voltmeter. Student, always remember, potential difference is connected with resistance in parallel and ammeter is connected with resistance in series. Now, let's say the potential difference across the length AB is AB and is denoted as VAB. That is from year till year. The arrows indicate the direction of the current flowing through this circuit. Now, we have to calculate that if the current passes in this circuit, how much heat is produced in this resistor. The amount of heat produced in the resistor is given as H is equal to I square RT. Now let's prove this formula. If Q energy flows through the resistor AB, then the energy received by the resistor is converted into heat energy. The temperature of the resistor will increase. If the resistor is replaced with motor, in which form the energy will be given by the cell get transferred into the energy given by the cell will be transferred into mechanical energy. If current is flowing through the circuit, electrical power can be given as energy upon time required. What is energy? Energy is total work done. Work done is, since work done is VQ, therefore power can be given as VQ upon T. Since potential difference is calculated across the resistor AB, V can be written as VAB. Since is equal to Q upon T. We can replace this Q upon T and power can be written as VI. This is given as equation number 1. If current is flowing continuously through the circuit, heat is produced in the resistor in time t will be given as H is equal to P into T, that is power into time. But we know what is power. Power is VAB into I. So substitute the value of power in heat. We get H is equal to VAB into T into I. This is equation number 2. Students, we know according to Ohm's law, V is equal to IR. That is potential difference across AB. If value of I is unknown, I can be calculated by rearranging this formula, that is I is equal to VAB upon R, that is equation number 3. By substituting the value of equation number 3 in 2, we get H is equal to VAB into T into VAB upon R. Student, always remember we are writing the value of VAB upon R in place of I. Now, VAB into VAB becomes VAB square into T upon R. This is equation number 4. Substituting the value of equation 3 in 4, we get, that is, since VAB is equal to IR, also VAB square is equal to I square R square. So heat becomes H is equal to I square into R square into T upon R. R and R gets cancelled and H is equal to I square RT. This is the equation for Joule's law. Therefore, student, this is the derivation for Joule's law. When Joule's law is asked to derive, you have to write this full derivation. And how you will state Joule's law? Joule's law is states as the amount of heat produced in a conductor is directly proportional to square of its current and directly proportional to resistance and directly proportional to its time to which the current is flowing. It means the heat produced depends upon current, resistance and time taken to flow the current. Using this formula, we can produce different formulas. According to Ohm's law, V is equal to IR. Also, R is equal to V upon I. Then the formula of heat becomes H is equal to I square. Substituting the value of R, we get V upon I into T. I from I square and I from denominator gets cancelled and the formula for heat becomes H is equal to I into V into T. This is second formula which we can get from this derivation. Now we can change into more forms. Since H is equal to I square RT, let's consider I is equal to Q upon T. Also, I square is equal to Q square upon T square. Substituting the value of I square, we get H is equal to Q square upon T square multiplied by R into T. 1 T from denominator and this T gets cancelled and the formula of heat can be given as H is equal to Q square into R upon T. So this will be the third formula. According to the given condition, we can use different formulas in numericals. Now let's calculate the unit of electric power. Since we know power is equal to potential difference into current, the unit of potential difference is volt and the unit for current is ampere. So students, we can say that when 1 volt potential difference is applied through a circuit to measure 1 ampere current, it can be given as 1 volt means 1 joule upon 1 coulomb. Student, since V is equal to W upon Q, that is potential difference is work done upon charges supplied. Unit of work done is joule and unit of charges is coulomb. So for 1 volt potential difference, 1 joule work is done when 1 coulomb charges are supplied. It is substituted in place of 1 volt, we get 1 joule upon 1 coulomb. Similarly, we can write for 1 ampere. Ampere is used to measure the current. Current I is given as Q upon T. The unit for charges Q is coulomb and the unit for time T is second. 1 ampere current is passed when 1 coulomb charges are supplied in 1 second. Substituting the value of I in ampere, we get 1 coulomb upon 1 second. So therefore, 1 coulomb gets cancelled and the unit becomes 1 joule upon 1 second. But student, we know 1 joule upon 1 second is watt. That is W. So student, the unit for power is 1 watt. Hope you all understood the topic. So students, today we have studied energy transfer in electric circuit and in that we have studied Joule's law. Thank you. Stay home, stay safe.